to make one reaction for all four. Okay? So I'm going to write this. Now I'm going to write nucleophile for that. So the nucleophile is going to be red box over here. So all the red boxes I draw going to be the nucleophile. Okay? So living group. Once it moves from there. Okay? So now, so what you're going to do is you're going to react with the water, right? Right? So now, these two, I'm going to rewrite the green color just to make it less confusing. So I'm going to write OH, which is nucleophile, right? So this has a green color there. Now, if you recall, two steps we just covered. So what do you think? What's going to be the product? How this reaction is going to proceed? So don't worry about the mechanism first, because I know water is weak nucleophile. So you're going to need catalyst, acetyl base. So it doesn't matter which mechanism it's going to follow, the product going to be the same. Right? They're going to have the same product. So first, let's predict the product. What's going to be formed? So remember two steps. So you're going to take the nucleophile. So you're going to add that nucleophile with the carbon, right? So the first step is going to be you're going to add nucleophile to the carbon, right? So this nucleophile, I can write over here. So you have the nucleophile, you're going to go over here, you're going to have the nucleophile over here, and then the leaving group. Okay. You have the nucleophile, right? So now this is addition, right? So number one, this is addition. Here we are. Right? So now what will be number two? Elimination. Right? So what do you do? You're going to remove that from here. So now nucleophile becomes living group when it leaves from the molecule. Right? We're going to call that living group. So now what's going to be the product of that? So the product is going to be like this. So R, C. So now you have OH, you don't have the nucleophile there, right? So this is the product. So now that's why you see this over here, the common product. So since you are reacting with water with all the derivative, so the incoming nucleophile is going to be OH for all of them. So they are the common product, that is carboxylic acid. Of course, you're going to have different leaving groups. So from acid chloride, you're going to have Cl minus burn out. From the anhydride, you're going to have the ester group RCOO bring out from there, right? So from the amide, NH2 minus is going to be the leaving group, and so on. So you're going to have the different leaving group as a byproduct in all these reactions. But the major product is carboxylic acid. Right? Clear for that? That is summary of all derivatives reacting with water. So now you can go individually with all the reactions. So that's the first we see there. So this is not new, the same reaction, right? So you have the acid chloride, you have water, you have the carboxylic acid formation there. So if you see the mechanism, then yes, you're going to have slightly different mechanism depending on weak or strong nucleophile you have. Since water is weak, then proton going to start the reaction, then nucleophile is going to go after that to the carbon, and then you're going to have living group out and carbon. Okay? So again, this is same thing like carbonyl. So in carbonyl reaction, if you have the weak nucleophile, normally the proton going to start the reaction from the oxygen center, and then the nucleophile is going to be added later, right? Same thing over here. So water is weak nucleophile, so you're going to have proton or acid catalyst. So that's going to start the reaction, right? So you're going to have that. So this is going to start the reaction from here, and then you're going to go from there. Okay? So that's the acid chloride. So now by anhydride again, so same reaction. This is anhydride. You have water, right? So you have the acid formation from there. Okay? And then ester. So again, this is ester you are adding water there. So you're gonna remove that from here, and then you're gonna put with that. That's carboxylic acid. Right? So the same conclusion slide. It's not new at all. And then so mechanism, acid or base. So depending on that, you're going to have the weak or strong nucleophile reaction. Again over here, if you have base, so base is going to start the reaction, and then you're going to have the living group out, and finally you're going to have the carbon, right? So if you have the acid catalyst, for example, acid catalyst, what do you do? You have proton, so you're going to start from here if you have a acid, from the oxygen center or the negative center. If you have base, you're going to start from the carbonyl carbon. That's the difference. Other than that, same, right? Amide, again, so same repetition. This is amide. What do you do? You have replaced these by OH, so you have OH over here. Again, carboxylic acid, right? So don't be scared with all the other group you have as substitute. Doesn't matter. Whether you have the ring, branch, linear chain, whatever you have there, don't care about that. See the functional group, see the carbonyl carbon. There at the center you're going to focus, and put whatever nucleophile you have on that, you have the compound. Right? So this is all about the reaction of derivatives with water. Okay? So now we're going to go to the second reactant. So now you're going to react with alcohol. So we are not doing reaction with water here. Our reactant is going to be alcohol. Right? So for alcohol, what do you have? You have two parts like water. This is also a weak nucleophile. So this is the nucleophilic part. So you're going to have RO minus. This is like nucleophile. Right? So now you're going to follow the same two steps like before. So what do? So you're going to add OR minus to the carbonyl carbon. And then whatever you have the living group there, you're going to take out. Right? Same two steps. So let's see. So from here, you're going to replace this by OR. So now you have OR over here. Right? So for the anhydride, you're going to replace all these parts by OR. So you have the same product. Right? And then if you have acid, for example, then you're going to do the same thing. You're going to place that, and then you have the OR there. So if you have amide, so you're going to replace this by OR, so you have that. Right? So what is the product? Product is ester. Right? That's going to be the product. So before you had acid, now you have ester. Because OR is the nucleophile produced by alcohol, so you're going to have the ester as a product. Okay? So this is the same thing for other. So whatever nucleophile you have doesn't matter. The same common two steps there. Okay? So that's the reason why. So the rest of the slides over here are the repetitive ones. So make sure first you know very clearly with water, and then you're going to use the same basic concept for all other reactions. So for your exam, you don't need to cover all. So if you go up to this point, it should be good. All other are just repetitions. So they're going to repeat again. Right? Good? So any question up to this part? All clear. Okay, then we're gonna review or repeat again the couple of slides. Ready? Alright. So we're gonna review.
This is so cool. It just shows you the chances.
Alright, so we're gonna review some today and then rest on Monday.
Yeah, that's nice. If you want to hurt yourself.
Alright, so question number 1. So you have the reaction, so you know the reactant, you know the reactant, you're gonna guess the product. Right? So, but before that, pay attention to what is the reactant you have, what functional group you have there. So this is like R, it is like R, and then you have the carbon, and then you have the oxygen, and then you have the hydrogen. It's like that, right? So focus on this one. So this carbon, and then you have the oxygen, and then hydrogen. Right? So remember, this must have 4 bonds, right? So how you can have 4 bonds? So you have that ring over here, and then you have the carbon. So you can have 4 bonds only if you do this. You have the hydrogen bonded to carbon and the oxygen bonded to that carbon. And on the other side you have the ring. That is, this carbon is exactly like that. Okay? So now what is this? This is carbonyl molecule. Specifically, if you call, that is called aldehyde. Okay, so you have the 1 hydrogen and 1 R. That's the aldehyde. So now it says what's going to be the product when you react amine. So I'm going to write like this way: Rn and S2. Right? That's the 1 degree amine. You have the 1 carbon nitrogen bond. So this is 1 degree amine. Okay? So when you react 1 degree amine or ammonia, so it can be either of these two. Okay? Or you have the NS3. So you can have that, or so either one of these two, either ammonia or the 1 degree amine. So the reason for that is you must have 2 hydrogens and the nitrogen that can be used for the reaction. That's the reason why this is another reaction like 2 degree amine or 3 degree amine. So you can have one class of reaction with 1 degree amine or ammonia. So now you're going to have the product. So if you recall the reaction of carbonyl carbon with different types of nucleophiles, so you had one reaction in there, reaction with the nitrogen containing nucleophile. Okay, you have the reaction there. That's what it is asking. Right? So now, obviously, how are you going to proceed the reaction? First, you're going to start from the scratch. Okay? So you have the plus, you have the minus over here. It is obvious for the carbonyl. These two are the center you're going to react. Nothing else, right? And then for nitrogen containing nucleophile, why you call nucleophile? You have the lone pair there, right? So you have the lone pair on the nitrogen. So now it is obvious that nitrogen is the reactive center for the amine. So now you're going to add one reacting center to the other one, right? So where are you going to add this nitrogen? To the oxygen or to the carbon? So obviously on the carbon, because negative goes to the positive, and you're going to have the one there. Okay? So now, after that, what are you going to do? So you lose the hydrogen from there, and then you're going to have the carbon-nitrogen double bond. So this is going to be out as the water molecule. If you see the mechanism, right? So ultimately, what you're going to have? You're going to have the double bond between this carbon and the nitrogen. So that's what you're going to have the carbon. Okay? So you're going to have that carbon, and then you're going to have the double bond with the nitrogen, and then you have 1, 2, 3, 4 carbon in that. So I'm going to write 1, 2, 3, 4 like that. Okay? So now you're going to compare the structure. So it looks like this one, right? You have 1, 2, 3, 4 carbon, which is this one over here. 1, 2, 3, 4. And then you have the carbon nitrogen double bond. Remember, this was the carbonyl carbon. Carbonyl carbon before. I'm not saying here, but this was the carbonyl carbon when you had the reactant. Okay, so you're going to add nitrogen on that carbon, and you have the carbon. So remember the name for this molecule? That right? Mm-hmm. Double bond, so imine. That's the name for that. So that's going to be the carbon. Right? Alright, so now we're going to go to the next one. So you're going to write the product, reactant. Yeah, so there's a typo. Okay, so this is the not product, reactant. Reactant. So you're going to predict the structure of reactant. There is no major and minor reactant. So you have the product, so you know the reagent, so what's going to be the reactant, right? So you're going to go backward. So now, if you see the change over here, so let's see this thingy, so where does this go? That should be the reactive center in the reactant. Okay, that's going to give the clue where you're going to make the change. So CN, you have CN over here. That CN came over here. That means this carbon should be the reactive center. Right? So if you see on the other carbon, do you see anything coming from the reagent? No, right? So CN is the only reaction you have over there. So this is the one. So this carbon should be the only reactive center that gonna change. So that means this gonna be the focus of yours. Everything else gonna be the same as the reactant. There is nothing changed. Okay. So now I'm gonna write the other part. So I'm gonna write over here. So I'm gonna write that. So you have the nitrogen containing, right? So this is R, you have 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. So I'm not doing anything. So this is going to be as is. There is no change on that. So if I put a box over here, so this is the no change part. Okay? No change. So you don't have any reagent adding over there. So now you have the CN there, so O there, that means you're going to have carbon and must have the oxygen over there. Okay? So then what else? So if you remove this reagent out from there, you're going to go to the reactant side, right? So now I'm going to remove this CN because it came from the reagent. I'm going to remove that. So now I'm going to put the double bond over there. So carbon should have the 4 bond, you don't have any other, right? So, but here you have one hydrogen, right? It's not shown there. So for the product, you have one hydrogen there. So one hydrogen over here. You should have 4 bond, right? So now you have that hydrogen already here. So that's the reactant. Right? So what is that? This is the carbonyl compound reacting with the nucleophile cyanide, Cn minus. So this is also the nucleophilic addition to the carbonyl molecule, like number 1. So here, of course, you have different nucleophile than number 1, right? So then which one? This one or this one? Right? So, any question on that? Clear? So you're going to trap with the reagent you have. So take the reagent out and then you're going to have the gas. What's going to be the reactant from that? So now, so you're going to write the product for this one. Okay? So again, this is carbonyl. So you have ketone over here, right? So ketone. Now, what's going to be the reactive center? This is obvious. So this is going to be the reactive center you have. Right? So now you're going to make some changes in that. So you're going to make changes on the oxygen. You're going to make changes on the carbon. Because these are the polar center, so plus and minus. Okay. Right? That's where you're gonna make the changes. So what changes you make? Based on the reagent, right? So lithium aluminum hydride, right? So the name hydride gonna give hydride, right? So this gonna give S minus, which is hydride. It's not proton, it is hydride. And then the number 2, second step, it is hydronium ion, that is, you're going to give S plus. So the first is going to give S minus, and the other is going to give S plus. You're going to do in a sequence, one at a time. So now, where you are S minus?
The carbon center.
Carbon, right? The nucleophile, so you're going to add over here. And then you're going to have the oxygen minus there. So you're going to add, let's write the column. So you're gonna add that other to there. So H minus gonna go to the carbonyl carbon. H plus gonna go to the carbonyl oxygen. So now you can guess the product. Right? So what's gonna be the product? So you're gonna have one hydrogen over here, OH over there. Okay, so I'm gonna write the product over here. So 1, 2, 3. So how many carbon you have? So make sure you have the equal number of carbon. So 1, 2, 3, 4 carbon on the ring. 1, 2, 3, 4. That's good. So now you have the O and C. So the green. So this hydrogen over here is going to be 1. This is from hydride. Right? And then the other hydrogen is going to be over here, OH. So this is from H3O plus. That's the difference. Right? So the hydrogen is nucleophile, it's going to go to carbon. And then the proton from the acid, solvent, whatever you have there, they're going to go to the oxygen. Right? Now you see the product. So going to be C, right? That's what it is. All good? Alright, so we're gonna name the seed. So how are you gonna name this? So again, you're gonna follow the same rules you have. So figure out the longest possible chain with the functional group nearby or within that. And then you're gonna define the parent, number the carbon, and then see the substituent on that branches, right? So you're gonna put it all together, you're gonna have the name for the molecule, right? Now, so how should I name? From left or from right? Can I do like that? 1, 2, 3, 4, 5, 6. No?
Oh, yes. You should. Yes.
Yeah, so remember, include the functional group. You should include that. Okay, so that's why my number is not good. So I'm going to modify a little bit so that now I'm going to write number 1 for that carbon over here.
Sneaky, sneaky.
So number 1 is going to be the carboxyl carbon. And then number 2, 3, 4, you can go whatever way you like, but should be the longest one. Right? So you will not have longer than this if you go to the other way. You're going to have shorter. So I'm going to do numbering like this. Okay? So now, if you have just the alkane, you're going to write hexane for that. Or 6 number, right? So now, you have the carboxylic acid over there. So OIC going to be the prefix, suffix for that, right? So you're going to write, you're going to cancel E with OIC acid. So now you're going to have the hexanoic acid. Okay, that's the parent. So hexanoic acid. This is the parent. So the parent name is fixed. So now you're going to see the branches on that. Okay? So if you have the functional group carbon other than the end, you can also indicate the position for that. But here, I didn't want the first carbon, this is obvious by default, you need to indicate the number for that is it. But so you have the substituent 1 over here, 1 over here, this is 2, this is 4. So you have 2 and 4. What do you have there? Methyl, right? Dimethyl. So your branch is 2,4-dimethyl. And the parent is hexanoic acid. So now you're going to combine both together, right? You're going to put the branch in front of the parent and then write it. So 2,4-dimethyl. So this is the branch you have. So this is the branch. And then hexanoic acid is the parent, right? So this is parent. Parent. So that's how you're gonna make it. Right. So which is the strongest acid? Acetic acid, chloro, bromo, fluoro. Okay? So let me write the structure of all of these. So you have the carboxylic acid in all of that. So you have CS3 over here. And then you have actually, I'll write this way. Let me show all the hydrogen here. So, here, review. So you have carbon and then hydrogen, right? On that, 3 hydrogen, like this. So you have the hydrogen, and then now you have fluorine for that. So for 1 you have fluorine. And let me do it in the same sequence. So first you have the acid, second you have fluorine. I will write fluorine Cl. And then I'm going to write bromine after that. So CH bromine. And then you're going to have the fluorine, right? Hydrogen and fluorine. So the difference in all these 3 is this one. So in acetic acid, you don't have any substituent there for the hydrogen. So you have CS3 next to the carboxylic functional group, right? And for the fluoro compound, you're going to have the chlorine substitution for 1 hydrogen. And then you're going to have bromine for the other one, you're going to have fluorine for the other one, right? So remember, we went through the inductive effect of the electronegative atom through the sigma bond for the acidity, right? So fluorine, chlorine, bromine, all are electronegative atoms. So they're going to pull the electron from the carbon towards it, and then that carbon going to pull eventually from the carbon, and then going to be easier to move the hydrogen. So if you have any inductive effect on the carboxylic acid, acidity is going to be increased. Okay, that means all these chloro, bromo, fluoro compounds are more acidic than the normal acetic acid. Okay? So that's why these are stronger than this one. Okay? Stronger than this. So this is the least one. So now out of these 3, which one is going to be the strongest? That's the one you're going to take.
Fluoro-acidic.
So fluoro going to be fluoro?
Oh, fluoro.
Right. So remember, you have the fluorine, and then you have the bromine, fluorine, right? Next you have the fluorine, bromine, iodine. So these are the order you have in the periodic table. So which is the most electronegative atom?
Fluorine.
Fluorine, right? That's the reason why this is the strong.